Assalamu alaikum everyone. Welcome to the course of ME 212 Dynamics. This is lecture 33 and in today's lecture we will discuss about the tipping or a slipping condition that usually occurs in case of the friction between the two surfaces. So in this lecture we will discuss about the tipping or slipping. Now what is the tipping or slipping? Let us say that this is a rigid body and this rigid body has a contact with any other surfaces. Let us say that it has a contact with the ground. So let us say that there is a force P that act on this rigid body. So condition may occur that this rigid body slide or slip over this surface and come to this stage. So this is the new location of this rigid body. There may be a case that this rigid body, like this is the ground, so this rigid body basically tip up. So in this case, this is basically this surface, this portion of the rigid body is not in contact with the ground, or in other words, it tip up. So there may be a case that when a force act on the rigid body, so the rigid body slip or the rigid body tip up. So in this lecture we discuss this thing in detail. Although you have learned this thing in the statics, but for the dynamics we will study this thing in detail in today's lecture. So imagine that you have a rigid body. So this is the rigid body. On this rigid body, force is acting. Let us say this is the force that act on rigid body, and this rigid body is in contact with the ground. So first step is to draw the free body diagram. So how can you draw the free body diagram? So let us say that this is the free body diagram of this rigid body. On this free body diagram, this is your center of the gravity, center of mass point. On this mass point, weight is acting, which is mg. This is the force that act. This is called as the P force that causes this, either causing the slipping or tipping. So on the low surface there is some friction force. Let us say that F small subscript f is the friction force that occur on this surface. Also there is the normal force. So while solving the tipping or slipping condition, we assume that this normal force act at a distance of x from the center of gravity, or in other words, this is the pseudo distance at which this normal force n is acting. And why we are basically applying the normal force not at the center but at a distance of x from the center of gravity? Because after finding the value of x, we come across that either the tipping will occur or the slipping will occur. So from the value of the x we will determine the condition. So that's why pseudo distance is to be assumed for the normal force to act on this rigid body. So if you have no idea whether it is a problem is of the dynamic or the static problem, so the first step is to check for the static solution. So the step one is to check for static solution. In the static, what we done, sum of the forces in x direction equal to 0, sum of the forces in y direction equal to 0, assuming that this one is your x-axis and this one is your y-axis. So in the present case, when sum of forces in the y direction equal to 0, we assume, so from this we get the value of n, and for the sum of the forces in x direction equal to 0, we get the value of friction force f subscript f. Assume that mass is given to you and the load P is given, or the force that causes either slipping or tipping is given. So after finding friction force and the normal force, so on this surface, which is like the surface which is in contact with the ground, there is some coefficient of the static friction. So the normal friction force that may possible on this surface is basically the maximum friction force that is possible is mu s time n. So from this case, if you find ff and compare this value with mu s time n, and if your ff value is greater than mu s time n, then this problem is basically a dynamic problem, and body will slip or tip. So this is basically, if you have no idea whether this is a problem is of the static nature or it is of the dynamic nature, so the first step is to check for the static solution. Find the value of the friction force ff. Basically, how can you find friction force? This friction force has to be equal to the p in this case, for the present case. So compare it with the maximum value of the friction force, which is mu s time n, and if ff is greater than mu s time n, this means that this is the maximum static friction force possible. So your force is greater than the maximum static friction force, so it means that the body is now is in the dynamic condition. So the body will either slip or tip. In other words, the body is not sticking with the ground. The body will either slip or body will either tip. So in this way you can this is the first step in which you can how can you identify the nature of the problem. This is about this. Now on the previous slide, the free body diagram that I have made is this one. This was your rigid body. On this rigid body, the total weight to be act at point G, which is the center of the mass or center of the gravity. There was the load P that caused the body either to slip or to tip, and there was a normal force N, and that normal force act at a pseudo distance x from the center of gravity. Also, there was a friction force F subscript small f on the surface which is in contact with the ground. This was your free body diagram. On the previous slide, we discussed how can we identify the nature of the problem, either the problem is the static problem or the dynamic problem. Now, for the case of the dynamic problem, when the body will be in the dynamic condition, body will either slip or body will either tip. So, to identify whether the body will be tip or the slip, the condition is to apply sum of the moment about point G equal to 0. This is the condition, and from this condition you have to find the value of x. On this, find value of x. After finding the value of x, let us say that the total width of this rigid body is w, and half of the width is basically d. So compare the value of x with d. If value of x if value of x is greater than d, then body will tip. So for the case of the tipping, this means that this portion is not in contact with the surface. So for the case of the tipping, your free body diagram will be like this. N will act at point D or at the edge, and this is your friction force. This will be your weight mg, and this will be your point P. This means that this portion is not in contact with the ground, or it is slightly above the surface, which is on which surface this rigid body is in contact. So this means that the total normal force will now act at the edge of the rigid body. Now when you identify that the rigid body is in the condition of the tip, so you have to follow the following conditions. That is, you have to apply some of the forces in x direction equal to max, sum of forces in y direction equal to may, sum of the moment about point G equal to ig alpha, and for the case of the curvilinear motion, the acceleration tangential direction will be equal to alpha time r. Now what is this r? This r is basically the distance from G point to the edge on which normal force is acting. This is your r. So these are the conditions that you have to apply for the case of the when the body is in the condition of the tipping. Now x is if your x is less than or equal to d, this means that your x normal force lie at a distance, some distance from point G. So when this is the case, it means that the body will slip. So when the body will slip, though, it means that you have to apply all these conditions, like sum of the forces in x direction equal to max, sum of the forces in y direction equal to may, sum of the moment about point G equal to ig alpha. You have to apply this condition, plus the other condition are that your friction force will be equal to mu k time n. this is the condition that you have to apply. As these conditions are related to the dynamic problem, is the problem nature of the problem is dynamic, so you have to apply these conditions. Thus this is the condition friction force. This condition you have to apply for the case when the body is in the slip condition. However, for the case of the tip condition, friction force does not equal to mu k time m. So these are the conditions that you have to apply for the case of the tipping or the slipping. So this is general concept about tipping or slipping condition of the rigid body. Now the method of solving the numerical problem related to this tipping or slipping. Now the method one is assume that the body is tipping. So after assuming that the body is in tipping, solve the force for the forces required to cause the motion due to the tipping. Now after first assume that the body is in tipping and solve for the force required to cause the motion due to tipping. Now second is to assume that the body is in slipping and then again solve for the force required to cause the motion due to slipping by using the steps that I discussed in the previous slide. Now after that you have to compare the two forces that you find out after assuming, first assuming by tipping and then assuming by slipping. Now after that, if you want to find out whether the motion whether the force that you are seeking is initiating the motion, then choose the smaller of the two forces. And if the force that you are seeking is to prevent the motion, then choose the larger of the two forces, since you want to prevent both the tipping or slipping conditions. So these are the conditions, or these are the method that you can follow while solving the problem related to the tipping or slipping. Now method 2 is first assume that the body is in the condition of the tipping or in the state of the tipping, and then solve for the force required to cause the motion due to tipping. Now after that, check to see how the friction force required for tipping compares to the maximum that can be generated at the surface. So if the friction force required for tipping is less than the maximum possible friction force that are generated on the surface, then the object tip and the problem is over. And if the force that causing the tipping is greater than the maximum possible friction force on the surface, it means that the body is in the condition state of the slipping. So if the object is slipping, then you have to solve the problem to obtain the force required to cause the slipping motion by using the steps that I discussed in slide number 2 or 3 of this lecture. So in this case, you can assume that the body will be tipping, or you can assume that the body will be in the state of the slipping, and then after assuming the slipping, then you can follow the steps. So it's up to you that how can you tackle the problem. Now this is the special case in case of the when the rigid body will slide or tip on the surface. So in some problem, the contacting surface may not be continuous, but rather at the two discrete points, the two surfaces are in contact. Like in this figure, at point A and the point B, the two surfaces are in contact with each other. So the free body diagram of the block now has a normal and the friction force at both point A and point B, as can be seen in this figure. So for this case, if the block is in the state of the slipping, impending is just before slipping, like at the verge of the slipping. At the verge of slipping or just before slipping. So in that case, we have Fa is equal to mu s time n and Fb equal to mu s time nb, and n and nb has to be greater than 0. So these are the conditions for the case of the slipping, or when the two surfaces are not in contact continuously, but at the discrete point they are in contact with each other. Now there may be a case that when the block will be in state of impending tipping, then in that case it means that this point is above the surface. That means that the normal force and the friction force at point A will be 0. So it means that the only normal force and the friction force will be at point B. So in that case, when the block is in the state of the impending tipping or at the verge or just below, just at the just slightly before the tipping or at the verge of the tipping. So in this case, we cannot apply FB equal to mu s time NB. So it is not equal to for the case of the tipping, and NB has to be greater than 0. So these are the conditions for the case when the block is in the state of the tipping. Now to solve the problem related to these tipping or the slipping conditions, the statement of the problem is, this is the problem 17-38 from your Hibbeler book. This is exercise problem, and the statement of the problem is a 150 kg uniform crate rest on the 100 kg crate and on the 100 kg cart. Determine the maximum force P that can be applied to the handle without causing the crate to slip or tip on the cart. The coefficient of static friction between the crate and the cart is mu s equal to 0.2. So you are given with the coefficient of the static friction. The mass is given to you, and the mass of the crate as well as the mass of the cart is given to you, and you have to find out the maximum force that can be applied to the handle without causing the crate to slip or to tip. Now, is in this case the given is that m equal to 150 kg. This is the mass of the crate, so m leading m squared, and mass of the cart given is 10 kg. Coefficient of the static friction given is 0.2. You have to find the maximum force P. This is the unknown. Now, after that, we can draw the free body diagram for the crate. So this is your crate, and the free body diagram, like this is your horizontal crate. On this crate, let us say that this is the G point, and on G point the total weight of the crate will act, and this is basically 150 times 9.81. This is the weight that act on this crate. Since this crate is in the contact with the surface of the cart, which means that there is coefficient of there is a friction force as well as normal force act on this surface. So we can assume that the normal force act on this surface is at a distance of x from the center of the gravity, and this is your normal force, and this one is your friction force. And let us say that this is the point B, and this one the end this point is A, and the dimension given is this whole dimension is 0.5, so this will be equal to 0.25, half of the width. And from G point to this edge the distance will be, since total height is 1 meter, so this will be equal to 0.5 meter. So this is the free body diagram for the present case. Now after that, in the methods we discussed it, we can assume either the tipping or the slipping. So in this case, our assumption can be like assumption. So we can assume that the crate slip before tipping. Slipping. So this is our assumption. We can assume that the crate tip before crate tip. We can assume, but in this case we assume that the crate slip before tipping, since this first the slipping will occur, after that the tipping will occur. So we assume that the crate first slip and then the tipping will occur. So for the case of the slipping, as in the previous slide we discussed that when the case of the slipping, the maximum friction force possible is mu s time n. So when Ff equal to mu s time n, so the coefficient of static friction given is 0.2, so it will be equal to 0.2 times n. Now after that we can apply the equation of motion on this rigid body. So the free body diagram that I draw in the previous slide was, this was your rigid body. On this rigid body, this was center of the gravity or center of the mass on which the total weight is acting mg. So your normal force which act at a distance of x, and this was the friction force. This was all about the free body diagram. So after drawing the free body diagram and we have assumed that the body is slipped before the tipping, so applying the equation of the motion and assume that this is your x-axis and this one is your y-axis. So in this case we assume this x-axis in the left direction is dead because the force is acting in the left direction, so this whole crate plus cart is moving in the left direction, so that's why we assume the x in the left direction is the positive direction. So applying some of the forces in x direction equal to max, sum of the forces in y direction equal to may, and sum of the force moment about point G equal to 0. These are the conditions for the translation motion we can apply. And let us say that this is the point A at which the normal force is acting. So the third condition can also be written in such a way that sum of the moment about point A equal to sum of the kinetic moment about point A. Sum of the kinetic moment about point A. So for the condition 3 we can use any one of the third condition to find the moment about point A or to find the moment about point G to solve for the unknowns. So by using the first equation, sum of the forces in x direction equal to max. In the present case, the force in the x direction is only the friction force. So the friction force F equal to mu s time n, which was equal to 0.2 time n. So 0.2 time n equal to ma. So m given for the grade is 150 a. Let us say it is the acceleration of this grade. This is the equation 1. By using the second equation, sum of the force about y equal to my. So in the y direction, the forces act are the weight in the normal force. So the normal force is acting in the positive y direction, so n, and the weight is acting in the negative y direction. So using negative sign, n minus mg equal to my. So since the crate is translating in the x direction, so it means that the acceleration y direction is equal to 0. So this would be the equation 2. So from this equation 2 we can write n minus 150 times 9.81 equal to 0. So this implies that n equal to 1471.5 Newton. This is the value for the normal force. So by using the third condition, sum of the moment about point A equal to sum of the kinetic moment about point A. For that we have to draw the kinetic diagram. So in the present case, the kinetic diagram will be like this is your rigid body, this is the point G, and this is the body is translating in x direction. So it means that from the point G, the force it act is ma, and it act at a distance of 0.5, and this is your point A. So applying the moment about point A, so sum of the moment about point A. So in the from the free body diagram about point A, the only moment is because of the weight. So sum of the moment about point A equal to sum of the kinetic moment about point A. So from the free body diagram, the moment about point A is because of the weight. So and with the condition that anti-clockwise direction the moment taken is positive. So the mg weight moment is acting in the anti-clockwise direction. So this will be equal to mg time x. And from the kinetic diagram, the moment about point A is ma time 0.5. So this will be equal to ma time 0.5. So in this diagram, in this equation, mass is given to us, g is given, acceleration is unknown, and x is unknown. So from now we have two equations. N is a for the a1 equation 1, and for a and x equation 2. So in the equation 1, by substituting the value of n equal to 1471.5, we can find the value of a, which is equal to 1.962 meter per square second. So substituting this value of a in this equation, we can find the value of x. So after finding the value of x, we got the value of x equal to 0.1 meter. Now after finding the value of x, we have to compare this value of x with half the width of this crate. As the half of the width of this crate is 0.25, so 0.1 is less than 0.25. So when this x is less than 0.25, which is half of the width of the crate, it means that our assumption is right, that is the crate slipped before tipping. So this means that our assumption is correct. Now as we have to find the value of the maximum force After finding these unknowns, we can find out now the value for the p. So for the value of the p, we have to again draw the free body diagram for the whole system and find the value of the p. Is we have to find the value of the p that can be applied to the cart without causing the crate to slip or tip on the cart. So in the statement of the problem, it is not we have given nothing about the friction between the cart and the ground. So we can assume that the normal force act on the two wheels of the cart is, let us say that this one is NA. We called it, this point is A, wheel A, and this wheel is B, and this will be NB. However, the coefficient of friction, or no idea about the friction is given between this surface between the ground and the wheel. So we can assume that no friction between cart, wheel and ground. We can assume this thing. And also the weight for the cart and the crate given is, this is the weight for the crate, which is 150 times 9.81, and the weight of the cart will be at somewhere here, let us say that, and this weight will be equal to 10 times 9.81, as the mass of the cart given is 10 kg. So after that we can this is your x-axis and this one is y-axis. So we can apply the equation of the motion in the x and y direction to find the unknown. Since the unknown is p, which act in the x direction, so we can apply some of the forces in x direction equal to ma x. So after finding the value of after writing the equation of the motion, we can find the value of the forces in x and y direction. Since in x direction the only force that act is p, so here and it act in the positive x direction, p equal to ma. So here this is about all about this system, or in the system, a system include the cart as well as the crate. So it means that the mass will be the cart plus crate. So it will be 10 plus 150. This is basically the mass for the system in time a. So in the previous slide we find the value of the a. So the value of the a at which the crate is moving is similar to the value of the a at which this cart is moving. So it will be equal to 1.962. So from this we got the value of the p equal to 314 Newton. So this is the maximum force that can be applied to the handle of the cart. So in this way you can solve the values, so you can solve the problem related to the tipping or slipping of the rigid body. So this is another problem from your textbook, problem 17-42 from the textbook of the Hibble. The statement of the problem is the uniform crate has a mass of 50 kg and it rests on the cart having an inclined surface. So determine the smallest acceleration that will cause the crate either to tip or slip relative to the cart. What is the magnitude of this acceleration? The coefficient of static friction between the crate and the cart is mu s equal to 0.5. So in this case, given that the mass of this crate is mass of the crate is 50 kg and the coefficient of the friction is 0.5, we have to find the acceleration. First step is to draw the free body diagram. So for the free body diagram for the this crate, so imagine that this is your crate, and this crate is making an angle of 15 degree with the horizontal. So on this crate, this is your G point. On G point the weight always act vertically, so this one is your mg. This is the weight for this crate, and let us say that the normal force acting on the surface, so let us say that this is the normal force, and this normal force act at a distance of x from the center of the gravity point, and also let us say this point is a, and at this point the friction force F subscript small f is acting. So we can first let us say that we assume that this crate is in the state of the slipping, so the crate slip before tipping. So assumption, we can assume that crate slip before tipping. So when we assume the value we assume the condition that the carrot slip. So in this case, our f subscript f will be equal to mu s time n, and this will be equal to 0.5 time n. This is the friction force. So as this weight is acting vertically downward, so we can assume that as the this crate is on the inclined surface, so we can assume that this one is our x-axis and this is our y-axis. So we have to write this weight in terms of this x and y-axis. So this means that the two components of this weight will be mg cos of theta and mg sine of theta, and this theta will be equal to 15 degree, similar to the angle between this horizontal and inclined surface. So it is all about the free body diagram. Now after that we can apply the equation of the motion to find the unknowns. So on the previous slide, the free body diagram that I have made was that this was the crate, or this was the G point on this crate, and G points the weight is acting vertically downward, and this crate is making an angle of the 15 degree with the horizontal. So it means that, and let us say that this is our x-axis and this one is our y-axis. So we can then split this mass mg into the two components, one in the x acting in x direction, one acting in the y direction, and this angle is 15 degree. So this will be equal to mg sine of 15 degree, it is in front of the angle, and this component will be mg cos of 15 degree. And let us say that this is the point A on which the normal force n is acting, and it is making it is at a distance of x from the G point, and the friction force acting on this surface is f subscript f, and we assume that this got slip before tipping. So we have to apply the equation of the motion. Sum of the forces in x direction is equal to max, sum of the forces in y direction equal to may, sum of the moment about point G equal to 0 r, sum of the moment about point A equal to sum of the kinetic moment about point A. We can use these equations to find the unknowns. So let us say that by using sum of the forces in x direction is equal to max. So this means that, and also the kinetic diagram for this rigid body is, you can write the kinetic diagram. This is the kinetic diagram, this is the point G. On this point G, this is your MA, and also this MA is making an angle of 15 degree with the inclined surface, as this MA is act horizontally on the surface. As this force is acting horizontally, this means that the acceleration on this card is also act in horizontal direction. So it means that we have then again we have to equate we have to then split this MA into two components. So the first component will be MA sine of 15 degree, and this will be MA cos of 15 degree. This is a kinetic diagram. So by using the first equation, sum of the forces in x direction is equal to max. So in the x direction on this free body diagram of this rigid body, the force that act is mg sine of 15 degree. This is the one force, and the second force is the friction force which act in the x direction. So mg sine of 15 degree act in the positive x direction. So mg sine of 15 degree, while the friction force ff act in the negative x direction, so it is minus 0.5 times n. This is all about the sum of the forces in x direction, and this is equal to max. So here the x component is ma cos of 15 degree, and it also act in the negative x direction, so it will be minus ma cos of 15 degree. This is equation 1. So by using the second equation, sum of the forces in y direction equal to may. So in this case, in the y direction, the two forces are to be acting, that is mg cos of 15 degree and the normal force n. As the normal force is acting in the positive y direction, so it will use a positive n, while mg cos of 15 degree act in the negative y direction, so it will be minus mg cos of 15 degree. These are the two forces that act on this rigid body, and it is equal to as mg sine of 15 degree also act in the negative y direction, so it is equal to minus ma sine of 15 degree. This is equation 2. So by using the third relationship, sum of the moment about point A equal to sum of the kinetic moment about point A. So in the present case, the moment about point A will be because of the mg sine of 15 degree and mg cos of 15 degree. As this n is passing through point A, so the no moment about point A. Also ff is also the line of action of this force is also passing to point A, so the moment because of the friction force will also be is also not included about this moment. So mg sine of 15 degree and mg cos of 15 degrees causing the moment about the point A. So because of the cos of 15 degree, like this is the perpendicular distance between mg cos of 15 degree and the point A, and this is creating a moment counterclockwise about the point A. So taking the condition that the counterclockwise moment is positive, so it will be mg cos of 15 degree time x. This is the moment about point A because of the y component of the weight, and now because of the x component of the weight, the moment about point A will be is this component here. This is the component acting at point G, and the distance from point G to point A will be 0.5. So the distance from, like if we draw the rectangle components to substitute, if we then split the components into the rectangle, so the perpendicular distance from mg sine of 15 degree and point A is 0.5. So and also it is creating the clockwise movement, so it is equal to minus mg sine of 15 degree time 0.5. So this is the sum of the moment about point A, and this has to be equal to sum of the kinetic moment about point A. So here this is your point A on the kinetic diagram. So also on the point A, the two moments are because of the mg sine of 15 degree, ma sine of 15 degree and ma cos of 15 degree, and it is equal to ma cos of 15 degree into 0.5, as the distance from here to here is 0.5. Okay, plus the distance from here to here is x, so this will be equal to plus ma sine of 15 degree time x. So this is your equation, this is equation 3. So from these equations, now the unknowns are the normal force n, acceleration a, and x. Now these three are the unknown, and also we have the three equations. So solving these three equations, we can find the value of n, x, and a. And after solving, the value of n will be equal to n equal to 447.81 Newton, a equal to 2.01 meter per square second, and x equal to 0.25 meter. Now after finding the value of x, we have to compare this value of x with half of the width of this crate, as half of the width is 0.3, as this x is less than 0.3 meter, which means that the crate will slip before tipping, and our assumption is right. So it means that the value of a for the present case is 2.01 meter per square second. So in this way you can solve the value problems related to tipping or slipping. Now this is the problem 17-43 from your textbook, and this is your homework. You have to solve this problem. So it is related to the special case when the friction is not continuous, but it is at specific points on the two surfaces. So the statement of the problem is determine the acceleration of the 150-pound cabinet and the normal reaction under the leg A and B if P is 35 Newton. The coefficient of static friction and the kinetic friction between cabinet and the plane is mu s equal to 0.2 and mu k equal to 0.15. The cabinet center of gravity is located at G. So here the normal forces will act Na and Nb at these points. This P force is given. So first you have to assume the static equilibrium. So from the static equilibrium you have to find the value of the P, and when you find the value of the P you have to compare it with 35. So if the value of the P is less than 35, this means that the body will slip. If the value of the P is become equal to greater than 35, that means that the body will tip. So when the body will tip, the total force is acting at point B. So in this way you can proceed by using the steps that I have discussed in the previous slides related to the special case of the tipping or slipping. So this is your homework, you have to solve this.